Okay, stats, we are on part B of section 5.1, and there's quite a bit of information in section 5.1, and so I think what I'm going to do is I'm going to even do one more video besides this, so we'll separate it into 3 parts, just because there's a lot of information in section 5.1, and I want to make sure that we get all the way through it. So in last video, we talked about a probability distribution, which kind of looks like this, and finding the average of that probability distribution. So finding the average is pretty easy. You just take the, each individual X value and take it times the probability. And then at the end, you add them all together, and then whatever you get as your answer, that's the average or the mean. Okay, so here we multiplied those together, and we found that if I'm flipping 2 coins, on average, I will get 1 heads, which is typical. That sounds reasonable. Okay, the next thing that we're going to do is we're going to find the variance and the standard deviation. Okay, we have to find the variance first. That is this sigma squared symbol, and then all we do as soon as we found that, we just take the square root of that to get sigma, which is the standard deviation. Okay, so let's kind of dissect and look at what these pieces mean. This guy is the sum. Okay, the x's are those the individual values. So I'll say our value. That's like the number of heads. So that would be like the 0, 1, 2, these numbers over here. Then we use that mean as our mu. And then P of X is the probability. So the probability for that row. Okay, they're going to have us do that same formula. There's another formula that we could use, but we're not going to mess with that one for right now. We're just going to do this one here since that's the heading of this column. Okay, so X minus mu squared times the probability of X. So our first X here is 0. So I would take 0 minus mu is going to be 1 every single time because that's what we found here. 0 minus 1 squared times the probability is 0.25, okay? We're going to get an answer there. So 0 minus 1 squared, this would be negative 1 squared, which is 1, and 1 times 0.25 is just 0.25, okay? Next, we have 1 here. We have 1 minus, average is still 1. So 1 minus 1 squared times 0.5. We're going to figure out what that guy is. And then let's go ahead and write out what the third one is. This would be 2 minus 1 squared times 0.25. Okay, so 1 minus 1 squared, if we look at that, at this piece right here, that's going to give me 0. So 0 times 0.25 is just going to be 0 for that middle piece. Okay, and then the last one, 2 minus 1, is 1 squared, which is 1, times 0.25 is 0.25. And then after I have all those done, I do the sum of those, and the sum of those is 0.5. So my variance, which is sigma squared, is 0.5. And then to find just sigma, I would take the square root, and the square root of 0.5 is something like, I don't know, 0.07 something maybe. Let me get that. Where my calculator go? The square root of 0.5 is 0.707. 0.707. Okay, and so that's what he looks like. All right, let's go down here. You guys have a sheet that looks like this guy, number 3. Let's talk through that one. Real quick, a sociologist randomly selects a single adults for different groups of 3. That are in different groups of 3, and the random variable X is the number in the group who say that the most fun way to flirt is in person. Oh, wow, they're really getting interesting here. Determine whether a probability distribution is given. So does this represent a probability distribution? It's kind of a silly example, but the way that we check that is to see, we add all of these numbers up, add them all together, and I'm pretty sure it does come out to be 100%. Let me check though. 0.091 plus 0.333. And we add them up, and it does come out to be 1, which is 100%. So it does, it is a probability distribution, yes. Determine whether a probability distribution is given. Yes, it is a probability distribution. If a probability distribution is given, find the mean, standard deviation, If a probability distribution is not given, identify the requirements that are not satisfied. So we don't have to do that part, okay? So we just need to find the mean, which is mu, and the standard deviation, but we're going to find the variance as well, okay? So to find the mean, we take these and we multiply them together. So 0 times that guy is 0. 1 times 0.333 is 0.333. 2 times that would be 0.85. And 3 times that, I can't do that in my head, 0.151 times 3, 0.453. And if I add those together, 0.85 plus 0.333. Oh, wait, I didn't do that right. There we go. The average is 1.636, okay? So this means that if I have a group of 3 people, on average, 1.6 of them would say that the most fun way to flirt is in person. Whatever. Okay, so over half of my group would say that. Okay, a little over half. All right, now we want to do the standard deviation. Okay, so I'm going to get rid of this stuff here. And we're going to, I'm going to do this column. This is the x minus mu squared times p of x. So the first one that we're going to do, x minus mu would be 0 minus 1.636 squared, and we would take that times 0.091. This was going to be a little bit uglier, okay? So that's the stuff that I'm going to plug in. 1.636 squared times 0.091. Okay, so this first number comes out to be 0.244. Okay, then I'm going to do the next one. So I would do 1 minus the average, 1 minus 1.636, square that, times 0.333. And that is 0.135. Okay, then I do start with 2. 2 minus 1.636 squared times 0.425. Third one is 0.056. And the last one, 3 minus 1.636 squared times 0.151. 0.281. That's what he is. Okay, add those all together. 0.244 plus 0.135 plus 0.056 plus 0.281. That gives me a variance of 0.716. Okay, if I take the square root of that, it is 0.846. Okay, that's my standard deviation. Okay, so that's what those two things are. Okay, now let's go back up here where we talk about the range rule of thumb. We're going to kind of go up and down. I hope I don't get you too nauseous here. The range rule of thumb for variance and standard deviation, or for standard deviation and mean. We talked about significantly high values, significantly low values, and the average or the mean is here in the middle. Okay, so values that are considered to be significantly high are 2 standard deviations above. So plus 2 standard deviations, and then significantly low values would be subtracting 2 standard deviations. Okay, so they ask us in this example, in example 3, we found that tossing a coin or 2 coins, the mean number of heads is 1 and the standard deviation is 0.7. Use those results and the range rule of thumb to determine whether 2 heads is a significantly high number of heads. Okay, so 1 is my average in the middle. If I add 0.7, 0.7, and 0.7, that would be like adding 1.4 to this guy, so that would be 2.4. If I subtract 0.7 and 0.7, that would give me like negative 0.4, which, I mean, is unrealistic. There's no way you can get a negative 0.4, but we'll just go with it. They say, is landing 2 heads a significantly high number of heads? Okay, anything that's beyond this 2.4 is considered significantly high. 2 is going to be somewhere here. So no, not a significantly high number of heads. Okay, So that's kind of how that works. Okay, significantly high numbers also are results of things that have a less than 5% chance of happening. So it's considered a significantly high number of heads if it has less than 5% chance of happening. It's considered a significantly low number of heads if it has a less than 5% chance of happening as well. Okay, and so I'm going to illustrate that down below here. I'm going to get rid of example 5 because I think I have a better example that might illustrate this a little bit easier. So I'm going to say the probability of having all boys when I have 5 births. Okay, do not write all of this down. Do not get bogged down and have to and write all of those down. If I'm doing 5 births, okay, 1, 2, 3, 4, 5. The first birth could be a boy or a girl, boy or girl, boy or girl, boy or girl, boy or girl. If I multiply those all together, that is 32 combinations that give me, combinations of boys and girls. I have listed all 32 of them out right here, okay? Because we're going to make this into kind of a probability distribution. So let's talk about boys first off, okay? Girls are kind of implied in this, but what could happen is if I have 5 births, I could have all 5 of them be boys, which is what I'm interested in looking at, probability of all boys. I could only have 4 boys. I could have 3 boys, I could have 2 boys, or I could have 1 boy. Now, the girl column, which they don't usually give us, but if I have 5 boys, that means I have 0 girls. If I have 4 boys, there's 1 girl, 2 girls, 3 girls, 3 girls, 4 girls, I need another column, 5 girls, okay? So those are all my combinations, okay? Now, so a lot of times they'll give you this probability distribution, but they will not put this column in here, just because that's kind of an implied scenario, okay? So let's kind of look at this. 5 boys, there is 1 combination out of 32 that gives me 5 boys, okay? 0 boys, there is 1 out of 32 combinations that give me 0 boys, which would be just girl, 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 okay? And then if we look at 4 and 1 combination, this is a 4 and 1 combination. Well, let me do a different color, okay? 4 and 1 combination for boys. So this has 4 boys, 4 boys. Let's see. Anything else have 4 boys? 4 boys. And 4 boys. And is that all? 4 boys, 4 boys, 4 boys. Oh, 4 boys. I missed one. So there's 5 combinations out of 32 that have 4 boys, okay? Now, what you will find is that there's also 5 out of 32 combinations that will have 1 boy and 4 girls, because it's kind of the same on the opposite end, okay? Then, if I go a 3-2 split, this one has 3 boys, 3 boys, 3 boys, 3 boys, 3 boys, 3 boys, and 3 boys, 3 boys, 3 boys. Oh my gosh, there's lots of combinations here. That might be it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Please let that pan out. 14, 15. Nope, we're missing 1. Shoot. 3 boys, 3 boys. Where's my other 3 boys? Oh, right here. 3 boys. So there's 10. Here, I'll just go over top of it. 10 out of 32 combinations, there are 3 boys. Then there is 10 out of 32 combinations that will have 3 girls and 2 boys, okay? So this is my probability distribution. Now, if I'm looking at the probability of all boys in 5 births, that is a 1 out of 32 chance of happening. 1 out of 32 chances is a 0.03, okay? That's a 3% chance that if you have 5 births, all of them are going to be boys, okay? So, since 3% is less than a 5% chance of happening, okay, we would say that all boys is a significantly high number of boys, okay? Saying that 5 boys out of 5 births is a significantly high number of boys is the same as saying 0 girls is a significantly low number of girls, okay? 5 boys is the same thing as saying 0 girls. So 5 boys is a significantly high number of boys in the same way that 0 girls is a significantly low number of girls, okay? Because both of those happen with 3% chance of happening, okay? So there's kind of how that breaks down, all right? Okay, let's go down here, and there's one more thing that I want to talk about. This is number 2 on this page here. The accompanying table describes the random variable x, the number of adults in groups of 5 who reported sleepwalking. So if I take a group of 5 people, 15% of the time, or almost 16% of the time, I had no sleepwalkers, okay? 32% of the time, I had 2 sleepwalkers and 3 non-sleepwalkers, okay? So if we look at kind of the other side of this table, 5, 4, 3, 2, 1, 0. Sometimes it's nice to do this. These are sleepwalkers, and these are non-sleepwalkers. Okay, so sleepwalkers, non-sleepwalkers. So the combination of 5 non-sleepwalkers and 0 sleepwalkers was 15%, or almost 16%. 4 non and 1 sleepwalker was 38%, etc. That's kind of how that works, okay? So find the probability of getting exactly 4 sleepwalkers among 5 adults. That's just read the table. Like, read the table and see what's happening. So exactly 4 sleepwalkers, there is a 3.1%. Or as a decimal, you can just leave it as 0.031, okay? Find the probability of getting 4 or more sleepwalkers, okay? 4 or more would be 4 or 5, so you would add those two together. So that would be 0.036 or 3.6%. Okay, now, which probability, this is the important part, which probability is relevant for determining whether 4 is a significantly high number of sleepwalkers, okay? Whether 4 is a significantly high number of sleepwalkers. Do we use the results from part A or the results from part B? Now, both of those are less than 5%, so 4 is going to be a significantly high number of sleepwalkers, or yes. So, but which one do we go off of, okay? Basically, we ask ourselves, does this number reflect 4 sleepwalkers? Yes, it does. Does this number reflect 4 sleepwalkers? Yes, it does. It reflects 5 sleepwalkers. The last person being a sleepwalker is just an added bonus, but both of these together is the number that I want to go off of when I'm determining whether 4 is significantly high or not. So I look at part B, which is the 3.6%. And then D says, is 4 a significantly high number of sleepwalkers out of 5 adults? Yes or no? Yes, significantly high, because 3.6% is less than 5%. Okay, if it happens less than 5% of the time, it is significantly high or significantly low, whatever you're talking about. Okay, so that's kind of how that breaks down. In my next video, I'm just going to go through this expected value, which is part 2 of the notes, but that'll get us through what we need to do today. So for the homework, what you need to do is you need to finish the part A. I think I have 2 parts of homework assigned right now. I have part A of the homework assigned. There was 4 problems on that. The 4th problem, I ask you to do a mean for a probability distribution, and you have to do a standard deviation. So you will have to go back to that 4th problem and finish the standard deviation on that, and then you should be able to do all of part 2 or all of part B for the homework assignment. So go online and do those things, and that'll be it.